Welcome to Tomorrow Unveiled, where we break down the news of the future before it's everywhere. Here's a question that's been keeping geroscientists awake at night. What if the drug that's already sitting in 40 million medicine cabinets right now is actually the first real anti-aging medication humanity has ever created? I'm not talking about some experimental compound that won't exist for another decade. I'm talking about a drug you've probably heard of. Ozempic, Wegovy, Semaglutide, the weight loss phenomenon that's been plastered across social media, celebrity gossip, and every health headline since 2023. But here's where it gets wild. The evidence suggesting it might actually slow biological aging, prevent dementia, reduce cardiovascular disease, and touch the root causes of aging itself. That evidence is striking. The mechanism is plausible, and the scientific community is genuinely divided on what it all means. Today, we're diving into the story of how a diabetes drug became a longevity breakthrough and what it tells us about aging itself. Let's start with something that'll sound familiar, but probably not the way you've heard it before. Ozempic, the brand name for semaglutide, was never designed to be a longevity drug. It wasn't engineered in a lab by gerontologists trying to extend human lifespan. It was created to help people with type 2 diabetes control their blood sugar. That's it. That was the whole point. The drug works by mimicking a hormone your gut naturally produces called GLP-1, glucagon-like peptide 1. This hormone does something pretty elegant. It tells your pancreas to release insulin when you eat, and it tells your brain you're full. Simple mechanism, straightforward purpose. But here's where the accident happens. GLP-1 receptors don't just exist in your gut or your pancreas. They're everywhere. Your heart has them. Your kidneys have them. Your blood vessels are lined with them. Your brain, the part that controls aging, inflammation, and cognitive function, is absolutely studded with them. So when you inject semaglutide, you're not just hitting one target. You're lighting up a cascade of receptors across your entire body simultaneously. And nobody really knew what that would do until people started taking it, and something unexpected happened. They didn't just lose weight. They started getting healthier in ways that shouldn't have been possible from weight loss alone. In 2023, the SELECT trial, one of the largest cardiovascular studies ever conducted, published results that made the entire field stop and stare. The trial followed over 17,000 people with obesity or overweight and existing heart disease. Half got semaglutide. Half got placebo. The question was straightforward. Does this drug reduce heart attacks and strokes? It did, dramatically. A 20% reduction in major cardiovascular events. That alone would have been significant news. But then the researchers did something interesting. They asked a different question. How much of that benefit came from weight loss? And the answer was only 67%, which means 33%, roughly one-third of all the cardiovascular benefit, had nothing to do with losing weight. It was something else. Something happening at the cellular level that was independent of whether you'd shed 10 pounds or 50 pounds. Dr. Eric Topol, director of the Scripps Research Translational Institute, put it this way. This is a class of medicines providing potent anti-inflammatory effects in the body and the brain even before there's 1 pound of weight loss. That single number, 33%, reframed the entire conversation. Suddenly, this wasn't just a weight loss drug anymore. It was something touching the fundamental biology of aging. And that's when things got really interesting. To understand what's happening, you need to understand something that aging researchers have been quietly studying for years. Inflammaging. It's not a household term. You won't find it on most health websites. But it might be one of the most important concepts in understanding why we age at all. Inflammaging is chronic low-grade inflammation. A smoldering fire that burns throughout your entire body for decades. It's not acute. It's not the kind of inflammation you get from a cut or an infection. It's systemic. It's constant. And it accelerates tissue deterioration in literally every organ, every single day. Your arteries slowly calcify. Your neurons accumulate damage. Your immune system becomes less able to fight infections and cancer. Your kidneys lose function. Your heart becomes stiffer. All of it, is driven partly by this background inflammation that your body never fully turns off. Inflammaging is such a fundamental feature of aging that researchers now consider it one of the hallmarks of aging, the core biological processes that drive the entire aging phenotype. And here's what makes GLP-1 receptor agonists remarkable. They appear to directly interrupt inflammaging. The evidence shows they reduce oxidative stress in kidneys. They decrease systemic inflammatory markers. They shift immune function in ways that suggest a younger, more resilient immune system. And they do it through multiple pathways simultaneously. One drug, one mechanism, hitting multiple hallmarks of biological aging at the same time. That's exactly what longevity science has been searching for. But here's where the science gets genuinely strange. Because if GLP-1 drugs are so good at fighting aging, they should work against dementia, right? Well, it's complicated. On one side of the evidence, there's a propensity-matched cohort study analyzing records from 142 healthcare organizations. They looked at 147,505 patients taking GLP-1 drugs and matched them against 147,505 patients who weren't. The finding, a 70% reduction in dementia risk among GLP-1 users. 70%. That's not a marginal effect. That's transformative. But then, something unexpected happened. Eli Lilly and Novo Nordisk conducted two massive phase 3 trials, Evoke and Evoke Plus, testing semaglutide in patients who already had early Alzheimer's disease. They enrolled 3,808 participants. They ran the trials for 2 years, and the results were nothing. No significant slowing of cognitive decline, no significant slowing of functional decline. The drug that appears to prevent dementia couldn't treat it once it was established. So what's going on? The leading hypothesis among researchers is profound. GLP-1 drugs may prevent dementia decades before it starts, but they can't reverse damage once neural pathology is entrenched. Prevention and treatment are fundamentally different problems. Think about it this way. If you spend 20 years protecting your brain from inflammaging, from oxidative stress, from the slow accumulation of amyloid and tau, you might never develop Alzheimer's at all. But if you already have Alzheimer's, if the damage is already done, a drug that reduces inflammation can't undo decades of neurodegeneration. That's not a failure of the drug. It's a revelation about how aging works. It's telling us that prevention is exponentially more powerful than treatment. And it's suggesting that the optimal use of GLP-1 drugs might be starting them in your 40s or 50s, not waiting until you're already sick. Early research from the National Institute on Aging and Yale School of Medicine found something that made headlines in the longevity world and barely made a ripple anywhere else. They measured biological age using DNA methylation clocks. These aren't guesses or estimates. DNA methylation clocks measure the actual molecular aging of your cells, how old your tissue is at the epigenetic level. It's not how old you feel, it's how old your cells actually are. And in their preliminary analysis, GLP-1 users showed a reversal of biological age by an average of 3.2 years. 3.2 years. That's not a rounding error. That's not noise in the data. That's a measurable, quantifiable reversal of biological aging. The improvements were strongest in 3 areas: brain health, inflammation pathways, and metabolic repair, the exact areas where aging accelerates fastest. Now, this is early research. It's not definitive, but it's consistent with everything else we're seeing. That GLP-1 drugs don't just help you lose weight, they touch fundamental biological aging processes, which brings us to a question that's starting to reshape medicine. If we already have a drug that reverses biological age, reduces dementia risk, prevents cardiovascular disease, and reduces inflammaging, why are we still talking about it as a weight loss medication? And that's when the story gets even more interesting. Until recently, GLP-1 drugs had a significant barrier. You had to inject them once a week, every week, forever. For people with diabetes or obesity, that was acceptable. It was medical. It was necessary. But for someone in their 40s or 50s who's perfectly healthy and wants to prevent aging, asking them to give themselves a weekly injection for decades is a huge ask. Then, on April 1st, 2026, the FDA approved Eli Lilly's oral GLP-1 pill, or Forglipron, starting at $149 a month. No injection, no needle. just a pill you swallow with breakfast. That changes the entire equation. Suddenly, you're not talking about a medication anymore. You're talking about an intervention that could theoretically start in your 40s, something you could take preventively, the way people take statins for heart health. The logistics of longevity just got dramatically simpler. And that's when the conversation shifted from, this is a drug for sick people, to, this might be something for aging people. Because here's the thing, we're not talking about a theoretical future anymore. We're talking about right now. There are already tens of millions of people taking these drugs. They're already part of a massive, uncontrolled longevity experiment. But before we celebrate, there's something we need to talk about. Something that's being quietly discussed in medical circles but hasn't made it into the mainstream conversation. Here's the uncomfortable part that everyone knows but nobody wants to emphasize. 15 to 40% of the weight you lose on GLP-1 drugs is lean muscle mass, not fat. Muscle. Editorials in the Annals of Internal Medicine have started warning about this specifically. Because for older adults, the exact population that would benefit most from anti-aging interventions, muscle wasting could be catastrophic. You could live longer, but be too frail to climb stairs. You could extend your lifespan, but lose the muscle mass that keeps you independent. You could reverse your biological age and simultaneously accelerate your physical decline. That's not a longevity win. That's a tragedy. So the field is scrambling. Researchers are investigating whether combining GLP-1 drugs with resistance training could preserve muscle, whether adding protein supplementation changes the equation, whether lower doses used intermittently reduce the muscle wasting effect. And here's the honest truth. We don't have clean answers yet. This is the hidden cost of the GLP-1 revolution. It's not just about weight loss. It's about what happens to your body composition, your strength, your ability to move through the world. And for a drug that's supposed to extend lifespan, that's a problem we need to solve before we start prescribing it as a longevity medication to millions of healthy people. But here's what's important. Knowing about the problem is the first step to solving it. And the field is aware. Clinicians are starting to address it, and research into mitigation strategies is accelerating. So let's zoom out and look at the bigger picture. Because what's happening with GLP-1 drugs is revealing something profound about aging itself. The Geroscience community has identified what they call the hallmarks of aging, the core biological processes that drive aging across all organisms. There are about 12 of them: genomic instability, telomere attrition, epigenetic alterations, loss of proteostasis, mitochondrial dysfunction, cellular senescence, stem cell exhaustion, altered intercellular communication, inflammaging, dysbiosis, altered metabolism, and neuroinflammation. They're not separate problems. They're interconnected. They amplify each other. They're the root causes of every age-related disease. And here's what's remarkable. GLP-1 receptor agonists appear to touch multiple hallmarks simultaneously. They reduce inflammaging. They improve metabolic function. They reduce cellular senescence. They protect mitochondrial function. They reduce neuroinflammation. One drug, multiple mechanisms. Hitting the system at multiple levels. That's not a weight loss drug anymore. That's not even a diabetes drug. That's a drug that's touching the fundamental biology of aging. And that's exactly what the Geroscience community has been theorizing could work. A drug that targets one root cause of aging and, in doing so, prevents dozens of age-related diseases simultaneously. If GLP-1 drugs really are doing that, if they're truly preventing dementia, cardiovascular disease, kidney disease, and metabolic dysfunction all through a single mechanism, then we're witnessing a paradigm shift in medicine. Not, here's a drug that treats aging, but here's evidence that aging has upstream causes, and we already have something that touches them. And that changes everything. Here's something that keeps researchers up at night. We're in the middle of the largest uncontrolled longevity experiment in human history. Over 40 million people are currently taking GLP-1 drugs worldwide. Not in clinical trials, not under careful observation, in the real world. Taking them for weight loss, for diabetes management, for reasons their doctors prescribed them for, and every single one of them is generating data. Real-world evidence, population-level signals about what these drugs actually do to human aging. Some of that data is being captured. Healthcare systems are tracking outcomes. Researchers are analyzing insurance claims. Observational studies are finding signals like that 70% dementia reduction that would never have been caught in a clinical trial. But most of the data is invisible, lost in the noise of billions of daily interactions between people and their biology. What we're seeing is the first real test of the hypothesis that targeting inflammaging and metabolic dysfunction could prevent multiple age-related diseases simultaneously. And the results are encouraging, contradictory, striking, and incomplete. Because here's the thing, it'll take decades to know for sure whether GLP-1 drugs actually extend human lifespan. We can't put people in a lab for 80 years and measure their lifespan. We have to wait for them to age. We have to watch outcomes over decades. But in the meantime, we have evidence from multiple sources pointing in the same direction. Population data showing dementia reduction. DNA methylation clock showing biological age reversal. Cardiovascular trials showing benefits independent of weight loss. Mechanistic studies showing inflammaging reduction. It's not proof, but it's a pattern, and patterns matter. Let me take you back to where this all started. A diabetes drug, something designed to help people regulate blood sugar. That drug became a weight loss phenomenon. Millions of people using it off-label, celebrities talking about it, social media obsessed with it. The narrative was simple: take the injection, lose weight, look better. But then something shifted. Researchers started asking different questions. Clinicians started noticing effects they didn't expect. And the data started pointing towards something much bigger than weight loss. What if the drug wasn't just helping people lose weight? What if it was actually slowing aging? What if the first real anti-aging drug wasn't some exotic compound from a biotech lab? What if it was already in millions of medicine cabinets? That's the accidental paradigm shift. Not intentional, not planned, but real. The Geroscience community is watching this unfold, and they're asking a question that would have seemed absurd 5 years ago. Do we already have a longevity drug? And if so, what does that tell us about aging? Hey, real quick, if you're enjoying this, do me a favor and hit that subscribe button and turn on notifications so you don't miss when we drop the next episode. These stories are moving fast, and you'll want to be in the loop. Oh, and if you're watching on your phone, there's a hype button right below the video. Smashing that really helps channels like ours get discovered. Because here's what I think is happening. We're at an inflection point. The evidence for GLP-1 drugs as longevity interventions is real. It's striking. It's not definitive, but it's coherent. Multiple lines of evidence pointing in the same direction. And that's going to force medicine to confront a question it's been avoiding. If we can slow aging with a drug we already have, what does that mean for how we practice medicine? What does it mean for prevention? What does it mean for our entire approach to health? Because once you accept that aging is a treatable condition, that you can actually measure it, slow it, potentially reverse it, everything changes. Your 40-year-old patient doesn't come in with high cholesterol. They come in with an elevated biological age. Your 50-year-old doesn't have diabetes risk. They have accelerated inflammaging. Your grandmother doesn't have mild cognitive impairment. She has early neuroinflammation. The language changes. The targets change. The interventions change. And that's not a small shift. That's medicine reconceiving what it's actually trying to do. So what happens next? The research continues. The real-world data accumulates. And slowly, either the evidence for GLP-1 drugs as longevity interventions gets stronger, or it doesn't. But one thing is certain. The conversation has already shifted. The idea that we might already have a real anti-aging drug, that it might be something we've been using for years without fully understanding what it does, that's no longer fringe science. It's the frontier, and the frontier is where the future gets built.
Let the future